Hi, LangChain and Autogen perhaps are the most popular frameworks when it comes to AI applications development. But sometimes user confuses between them, which one to choose to develop an AI applications. There are some fundamental differences between those two frameworks. In this video, we are going to dig deeper to understand what are the major differences between these two frameworks, so that you can make a better decision while choosing one. At least both the frameworks are very popular as far as GitHub statistics are concerned. They have significant number of stars and forks on GitHub. What is LangChain? LangChain, as per its description, is core framework for building LLM applications with chains, agents, and memory. And on the other hand, Autogen, what it is? It is a multi-agent conversation framework by Microsoft Research. So you can guess already, LangChain is a fixed pipeline single agent system, and Autogen is basically provides you with the orchestration capabilities for multiple agents. So in fact, that is the very basic and most important difference between those two frameworks. In details, we will dive deeper in a bit. In LangChain ecosystem, you have more projects like LangGraph, LangSmith, LangServe, and many other things. But we are just focusing on the conceptual and theoretical aspects of both the frameworks. Let us start with LangChain. So this is a basic pipeline structure which most of us are used to already, perhaps. This is a basic retrieval pipeline which I am trying to demonstrate here in form of this flow diagram. So you have documents, you have text splitter, you have chunks, and out of those chunks you have a vector store created. Then you retrieve the information and pass it to LLM. That's pretty much it about LangChain. Let us dive a bit deeper into it. So what are documents? Documents are any kind of information. For example, it could be PDF files, it could be your web pages, it could be your actual database itself. Then you have your text splitter. What it does is it breaks down large documents into smaller uniform chunks. Now, how does this chunking happens? What are the best strategies? This all topics we have already discussed in our series called How to Implement Efficient RAG. Please feel free to check that out. And if I say how to implement a text splitter, this is a code snippet. For example, here is a character text splitter. You have chunk size. It might be words, it might be characters, it might be tokens. So there are different strategies to define what is a chunk size. Then you have overlapping size. And at the end, you can create the chunks out of your document. So whatever you pass it, and you have a list of chunks. And then those chunks goes to a embedding process or a vector store. So embedding and vector store. Embedding converts text into chunks, into numerical vectors, and vector store embeddings and enable similarity search. And this similarity search is achieved by storing embeddings in a multi-dimensional space inside vector store. And if I have a look into the code snippet, it's very simple. There are multiple types of embeddings available in the market. You can use others as well. Here, for example, I have used OpenAI embedding and Faz as a vector store. So when I say embedding means your numerical representation of your text. While creating vector store, you pass in your text and embeddings, text which we have created the chunks here already, and we pass it on to for the embedding process. And at the end, you have your vector store. So we have our embeddings and vector store ready. Now it is time to retrieve some information. So which information to retrieve? Of course, you will have to have some query that is coming from user. User asks something, then this retriever gets activated. Its job is to fetch most relevant document chunks based on query. You created n number of chunks. You have a vector store where all chunks are staying in their numerical representations. Now you need to find out the similar chunks which might be the response of the user query. So this is the process of retriever. So retriever, how to do that? So you define a retriever with a type of the similarity. It might be cosine similarity, it might be Euclidean. There are various ways. Again, feel free to watch out the series, how to implement RAG efficiently. And then you have a top K parameter where you tell your retriever, okay, I want top 5 matching results out of vector store. And then you have user query and you pass it to your retriever. And you have your relevant docs retrieved here. This is the result, means top 5 results out of your vector store. Then these top 5 results goes to LLM. Then LLM uses its intelligence to find out which are the most matching chunks, which are the most matching documentation which has been retrieved from vector store, and prepares the final result. So language model that generates the final response using retrieved context from the vector store. And how to implement that? Again, there is a prompt, simple prompt, what you are going to use your LLM for. Answer based on the context. I have a context or the chunks are interchangeably being used here. So by context, I mean here is the relevant documentation, relevant chunks which has been retrieved from the vector store. And then some input parameters, you pass the chunks into it and the question. Then you pass this prompt for the final response to LLM. For example, here again I am using OpenAI models. You can choose a model of your choice and the key and all that stuff you can implement in your code and you have a final response. So this is how typically a retrieval pipeline is working, which you have implemented using LangChain. So what are the major properties you would have observed already in this pipeline? These are as follows. LangChain retrieval chain, it follows a fixed and linear pipeline. It is fixed, where there are ingestion steps where you feed the data, where you have lots of data in form of PDFs, databases, web pages, whatever it could be. Then you have a retrieval step where you retrieve the data from. So they together form a retrieval step. You have data, vector store, and retrieval itself. Then you have another step called generation, where the AI comes into the picture. So if I go back to the diagram, what is written there is all those from documents until a retrieval system, it is all can be categorized as a single thing, that is retrieval. And at the end we have LLM part, which actually is the AI entry into this flow. So that's what it is written. So key components are retrieval, chain, links, retriever or vector store, and LLM. So your retrieval system here is linked with LLM. That's all about it. That's all about a LangChain retrieval chain. What is the drawback about this flow, this implementation, this system? That is, it is fixed and linear and it is not autonomous. User enters something, it might be a task or a simple query, and retriever tries to find the relevant information from vector store. Those relevant chunks are sent to LLM and a fabricated response, some add-on on the top of these chunks. Maybe LLM decides, okay, 3 chunks are very relevant, so I will combine the response in a way that it covers the content of these 3 chunks as well, and it adds on some more information. So that's it. But what if there is no relevant information is found in the vector store itself? In that series we have discussed this in detail, that even if there is nothing matching, vector store will still give you the top K results. If you have written the K equal to 5, you will still receive some 5 responses, 5 chunks. Then you further need to filter them on the basis of scores. So we will not go into that detail, but you might have the wrong information out of vector store. some point of time. And another is if the user query is of a task type rather than a query type, where it says, for example, write me a Python code which prints Fibonacci series starting from this number. Can it do that? It at max can find out how to write a Python function, what are the syntax, semantics, such kind of documentation it can retrieve. But it cannot go back and forth and get your things done, and it loops until then. It cannot do that. That's where the agent comes in. Before we actually discuss the Autogen, we have agentic capabilities in the LangChain framework itself that we are going to discuss in our next section, that is LangChain agent. So that is unlike the fixed pipeline where all the information, all the operation flow is from left to right and finishes. Here there is some looping happening between agent executor and React agent. So let us dig deeper into this thing. We are yet discussing LangChain framework. We are not into Autogen still. Please note that out. So what happens in case of LangChain agent? There are two major key components, agent executor and React agent. And they speak to each other, they pass their observations, and this passes the actions to be taken until there is some interruption happens or a termination happens or a user task is accomplished. So how it happens is, let us discuss this agent executor first. So what this agent executor does is, it's a runtime orchestrator that manages the execution loop. This is the main engine. Its responsibilities are receive user tasks or query from here and provide the final answer. And it calls React agent repeatedly. Before it reverts with the final answer, a lots of looping happens between agent executor and React agent. Number 3, it parses LLM output. So when I say LLM capabilities in this design, in this agent executor LangChain agent system are available only with React agent. By the way, React is a short form used for reason and action. So the action and reasoning are the responsibilities of this LLM part, or you can call it React agent. So whenever I say LLM, it means React agent here. It parses the LLM output. Mean this agent executor parses the output of React agent and it executes selected tools. Means this might have given it with some tools, or it would have suggested it agent executor with some tools. We will see an example where we will discuss how the whole workflow happens. Then this agent executor executes selected tool, feeds observation back. After execution of the tools which React agent has suggested out of this tool pool, for example, so it gives the observation, the results back to React agent. For example, like asking, okay, I have executed what you told, now I have this result, what to do next? So this is kind of the main reasoning brain, and agent executor is, it executes what brain has suggested. So that's a basic terminology if I am to translate it into the simpler terms. So it calls React agent again with tool result appended to prompt. For example, so here is an example. It called some tools which were suggested by React agent, and it returns this observation back to this guy, the React agent. What is observation? The search tool returned 5 documents about Python. Somebody was learning about Python, and then it would have sent the query, user query to React agent. React agent would have suggested do a web search. Then agent executor actually executed those tools, and this is a result of the tools which is being sent to React agent again. So that is how it basically works. So React agent LLM reads this, decides next step, reads this and decides next step. So this observation is read by this React agent, and then it further suggests. So loop stops when, so it should not go in the infinite loop, it has to stop. So there are multiple conditions. For example, loop stops when React agent returns final answer. So if it returns a final answer keyword in the response that is coming from React agent. So React agent is the guy who will decide that the final answer has been achieved, the user task has been accomplished, not action. Executor extract this and returns directly to user. So this is the this might be one of the criteria. Another might be manages max iteration limit. For example, agent executor also starts a counter. Just for example, if 20 iterations of messages to and fro have happened between agent executor and React agent, I will terminate. So that's a kind of hard termination, but it also prevents the infinite looping situations within these this system. So its key roles are controls how the loop runs, never directly calls LLM because LLM calling is the responsibility of this React agent. It just does the things which this React agent suggests and always goes through React agent component for the suggestion. We will see the sequence diagram in a bit. Now quickly discuss this React agent's role, responsibilities and everything. So this is a brain, as we discussed already. It has a reasoning policy, LLM plus a special React prompt that teaches LLM to reason step by step. I don't think this is a new thing. Whenever you interact with LLM, you always have some system prompt along with the user query. So I think this is speaking about like that. It has components like LLM, GPT-4 or whatever, React prompt template. So one of the template from the hub or open sources you can use, or you can define your own as well. Tools description list. So it has access to several tools and their description, what they do. That's why it is able to suggest agent executor that execute this tool with that many parameters. Along with parameter, it gives the response back to agent executor. So it has access to tools as well, set of tools. And tools, it could be anything. It could be like search tool which searches through the documentation. It could be calculator, it could be web search, database. And in recent days, we have this nice MCP server implementation which exposes several tools, resources, prompts. So it has access to several tools, but it doesn't execute. Execution is the responsibility of agent executor. So there are standard keywords or terminologies used between agent executor and React agent message exchanges. For example, thoughts. Thoughts are LLM reasonings. So this field is filled by React agent. Actions, one or more tool names, action input, the tool parameters. Observation, that comes from agent executor. Observation is basically the result of what has been suggested by React agent, and agent executor has executed those many tools, and after execution the result is kept in the observation field. And the final answer, that comes from this thing, along with whenever this final answer property is available and there is no action needed. This is also important. And in the field we see no action, then agent executor decides, okay, the task is completed, now the final answer can be sent to, for example, to user. Now the critical things, LLM decides when done. Task completion signaling is responsibility of React agent. After each observation, LLM asks itself, do I have enough info to answer completely? If not, output action. If yes, output final answer. So whenever it believes that the task is completed and I have enough information for solving a user query or fulfilling the user task, then it says, okay, this is a final answer. It adds this keyword into the response to agent executor and the things are done. Otherwise, it fills it with the action field here, what next to do, which tool to call, or what other things to do. Then the key roles of the React agents are like decides what to do next and when task is completed, outputs text only, never executes tool explicitly. So execution is not the responsibility of this guy. It can only provide a kind of consultation to agent executor, that I believe according to your response, that many things I can suggest you, go and execute and tell me the result. So does agent executor only passes on the user query or result of the tools? No, it also have some memory. And what is memory? Memory is built up by the conversation history. So sometimes it is also useful that agent executor along with the user query or along with the tool's execution result, it also sends the history, the conversation history as well. It is very important for the context building, which really helps LLM at the end to do better responses, accurate responses. So this is the overall picture how LangChain agent works. So now let us have a look into an example. For example, if a user asks what is LangChain, which AI application are built using the LangChain framework, for example, what will happen? From the agent executor, this query will be sent to React agent. Then LLM generates this text, means React agent will generate this text with the fields. Please note those keywords. Thought, we already spoke about those keywords here. Thought, action, action input, observation, final answer. So they will be used while responding to each other, from agent executor to React agent, from React agent to agent executor. So the React agent, after receiving the query, gave this thought: I need to search documentation to answer this thing. What thing? This user query. And what it need to do is, it will suggest with some action. Action means some tool. So this tool search doc should be called with the keyword with input parameter LangChain. So this is doing a consultation to agent executor. This is my thought and this is the action you should execute. Then executor or agent executor executes this tool with this parameter and returns with the observation or the result of the tool execution. So after the executing search doc with LangChain parameter, this was the result. LangChain is a framework for building LLM apps. Now React agent or LLM reads this output, the observation that is coming from agent executor, and it gives its thoughts back to agent executor. What are the thoughts? I have partial info, but user also asked about real life project, need more info. So there is a action. So user was asking not only about LangChain, but he also wanted to know the AI applications which are built using the LangChain framework. So this is an action. Then LLM generates this text. It thinks, or the thoughts it developed were, need real-time example, and then it suggests agent executor a new tool. It says, okay, use this tool web search with this input parameter, LangChain based real life projects. So now this tool might be a vector store or anything else. The execution is the responsibility of agent executor. Then it will call these tools. After the execution of this web search tool with this parameter, this is the output. So output contains, obviously, in the best case, the projects which are developed using the LangChain framework, project XYZ123 whatever. And then LLM or React agent provides its thoughts. Now I have complete info for both parts. Now can answer user completely, and it tags it as a final answer. And final answer field is containing the full and final response, which is a combination of two cycles. The responses which were generated by this React agent in two cycles. LangChain is a framework for building apps. Then project 1, 2, 3 in e-commerce are based upon LangChain framework. So this is an example, and if you want to see a sequence diagram that will make the things even more clear, are like this thing. This kind of sequence diagram you would have seen in networking, where we draw the TCP HTTP message exchanges between user or client and server. So I tried to draw a similar diagram for the message exchanges happening between various entities in this system. You have user, you have agent executor, you have React agent or LLM, and you have certain set of tools. Of course, there is also memory, but the memory or history I have embedded in the message exchanges itself. So very first step, user query comes in. Agent executor passes this query to React agent along with the history, if any. If there is no history, just pass on the pure user query. Then React agent returns with some tool names and the input to call those tools with. Then agent executor goes to tools and execute those tools with the input, gets the output, then pass the output to React agent once more. And this cycle goes on and on until a final response is reached. Then again this observation, after this observation, maybe a React agent decides that still there are something missing, you should do it again. So it returns with some new tools, as we have seen in our example, and the cycle goes again. This execution of the tool happens, then the tool execution result is received by agent executor, and that is passed back to React agent. Then React agent again tries to identify whether it's a final answer or not. If not, and this cycle goes on and on. Once a final answer is achieved, this agent executor receives this property field with the response, and after parsing or further prettifying the response, the user is given the final response. So this is how the whole call flow between various bodies in this system works. So just do a quick revision. What are LangChain agents? Purpose is general purpose autonomous system, and this makes it totally different than our first retrieval flow. Here is no autonomy. It's a pure information flow from left to right. That's it. It never returns, no looping, nothing. So here is general purpose autonomy to accomplish tasks using available tools. So the process, how it works is, it's dynamic, cyclical reasoning loop occurs between React agent, which is LLM capable, and agent executor. There are certain tasks involved in the process, which are tools. Reasoning happens, then action happens, then observation, the tool's execution result, which is returned back to React agent, and the repetition happens. The major components in this system are, you have a reasoning engine, which is this React, this LLM thing. You have certain set of tools here. You have prompt templates, how your LLM or React agent should behave, what is the expectation. Then you have output parser, finally in what format you really want to give a user kind of response you want to give to user. Then you have agent executor, this guy, and memory. That's also important. The conversation history. So the key components are still two, this agent executor and the LLM. Autonomy is the biggest property of LangChain agent than the previous retrieval pipeline. So there are two types of workflows or pipelines we have discussed. Within the LangChain, we are not yet into the Autogen. So the next is Autogen. So do not get overwhelmed by looking at the diagram. This is very simple. I'm going to explain everything step by step. So Autogen is about orchestrating multiple agents. What do I mean? If I ask you to just black box everything, black box all this stuff into a single box, so that single box will become something like this dark purple colored block here in this diagram. Unlike here, where you see the flow, and this is a kind of standard flow. At least in most of the cases, it will be working like this. Similarly here, this is also a standard workflow for LangChain, typical retrieval system implemented using LangChain. But here I'm just giving an example. So there is no fixed workflow like this is a step one, the information flow should be from this guy to that guy. Everybody here is autonomous. Everybody here, at least these dark purple colored boxes, are agents and they behave autonomously. Autogen is a framework to bring multiple agents together. So one agent is an autonomous system like built with that many entities, memory, agent, executor, maybe. Although this is a LangChain API, LangChain system, Autogen would be having different things. React agent, tools, and of course a user there. So each agent has a lots of things inside it which you really need not to implement by yourself. That is the beauty of Autogen framework. So here to define an autonomous agent, you are needed to implement an agent executor, then a React agent, certain number of tools, memory, that you can do in a single step using Autogen APIs. Autogen tries to facilitate user for the orchestration of multiple agents and the creation as well. So here in this example, I am having an autonomous system made up of 4 agents which are doing a kind of coding. It's a software development team where we have a user task, of course something to develop, something to code, and we have this group chat manager. Out of these all agents, I declare this to be a kind of coordinator. So what this group chat manager does is, it's also an agent. First of all, it coordinates multiple agents in a group conversation. Important, in this whole system, there is no main agent. All of them are autonomous. All of them are having inside them agent executor kind of thing, React agent kind of thing, some LLM capabilities, some memory, but that is dependent up to the Autogen implementation. That's all black boxed. You never need to worry about how to create this specific agent. Most of the times the behavior is controlled using a system message. That's it. Okay, let's move forward. So important, no main agent is in this concept, in this system. All agents are equal. Manager coordinates but doesn't dominate. Each agent can contribute based on the selection modes below. So what it controls it chooses a speaker when the user query comes in. Before giving final response, again here are lots of looping happens, but looping is not between only 2 bodies, rather than the looping can happen among all of them, among all of those agents, and multiple times. So once a user query comes in, group chat manager chooses a next speaker who will be the next participant in this task. So there are various modes. There is auto mode, that is like LLM deciding which makes sense as a next speaker or next contributor. For example, if a user asks again, write a Python code which prints Fibonacci series, it might ask a next agent which is acting as a developer. Another mode could be round robin. It always goes in a special or specific sequence, one after another, randomly chooses. Then there's a random mode as well. Then we have a manual, maybe based on some specific conditions. This coordinator decides which agent comes in and does its job. So how we instantiate this group chat manager, I am just giving some syntax to make things a bit clear from development point of view. You need to create a group chat object which have the information about all the other agents it is coordinating with. Then messages if it want to pass on to other agents. Maximum round, that is a very important property, which is a loop prevention strategy, which we will discuss in a bit when we discuss this termination conditions. And speaker selection method. So this is a mode which we were speaking about. This auto is the safest and mostly used mode. Now with this group chat, we create a group chat manager. We just pass this group chat object here along with the model which we are going to use. So in every agent system, we have this React or LLM factor. So here we were digging down how a autonomous agent works, and we were able to see the various parts inside it. But here we have black boxed everything, or Autogen helps us not to dig deeper and not to code by yourself everything. So it has black boxed everything for us. So inside it, it's having a LLM capability. That's why we are giving the LLM model to it. So manager is an orchestrator. It's not a conversational agent. It usually doesn't need system messages unless you want to customize speaker selection logic. Next is start conversation. So this part is like if this group chat manager agent want to speak to other agents in the system. For example, this user proxy agent, which is acting like a tester in our software development team. This is declared in the diagram here. User proxy agent executes code, call functions, reports results. So it is basically a kind of tester for our development team, software development team. So you need the testers or user proxy agents object, and you can call this function initiate chat, and here you pass on the group chat manager object along with the task you want your tester agent to perform. So that's how the basic communication happens between the agents here. So we have this group chat manager, which is a orchestrator or coordinator. Then we have this assistant agent, which is a developer, the brain, which writes the code. So LLM powered conversational agent generates responses, writes code, plans solution. So whatever task comes in. By the way, in this example, we are going to build an autonomous system made up of autonomous agents, which all forms a kind of software development team. So your use case can be anything else. So here we are doing LLM powered conversational agent generates response, write code, plan solution. Capabilities are reasoning and decision making, of course, code generation, and it can call again some tools. Web search, DB query, API calls from MCP server, for example. Here is a syntax, a basic syntax example. You have assistant agent or software developer. Name this system message. Now here the system message decides how your agent is going to behave. Pretty much with this system message only, you can define very complicated autonomous systems made up of autonomous agents. That's the beauty of Autogen. So this is only the system message. You are a helpful coding assistant. Of course, you would like to write a few more lines, describe more things. But here, for example, this system message alone makes this guy a developer. That's it. You need not to manage anything else. You have options to manage many more things in the API, but that's the very minimal you will have to do. So its key roles are think and plan, and it doesn't execute code or tools itself. It writes code, then it will delegate it to user proxy agent, which is our tester. So let us see what it is doing. Its responsibilities, the user proxy agent, which is actually the tester, acts on behalf of user. It will mimic itself as a user, that I'm going to use your code, I'm going to use your software. It executes what assistant agent, the developer, proposes. And what are its execution capabilities? Of course, code execution, whether it's a Python, Bash, or written in any other language, whether it should use it locally or it should instantiate a Docker container. It can still use the tools available, and it can also ask human input at any time. I'll give you an example. If you would have used the coding agents, any kind of Gemini, CLI, or this GitHub Copilot, sometimes while execution it asks for the permission that I'm going to install this package, or I need to kill that Docker container, I need to execute this sensitive command. So there is a user interaction which is required there for XYZ reasons. So here we are speaking about such human input requests. And the workflow looks like it receives codes and functions from assistant agent and executes it in safe environment. It decides by itself how it want to do that. And it captures error outputs if anything happened like that, and reports the result back to assistant agent, then it will correct. Now you can correlate it very much with any coding assistant. That's a very interactive loop between user, between like the autonomous agents which are working behind the scene in a coding agent, which executes a command, reads the terminal. If any error happens, then it updates the code, then it finds out new things, then it decides, okay, this apt package is missing on your machine, or a Python package is missing in your virtual environment, and it installed that. So that's the kind of looping it happens in the whole workflow. So configuration examples are like any other thing, any other agent we have defined. User proxy agent, you will define human input mode. You can say never if you don't want. And max consecutive auto reply means that 10 times it will do a auto reply. After that it should terminate, means this error happened, I tried this, then assistant agent will say it like, okay, I have updated it. So this to and fro communication between two agents, it's max 10. You can define a limit here. Code execution config, which working directly should it use to generate logs, for example. Then like use Docker or run it in the host directly. So such properties you can define. And defining an agent, you would have already guessed, it's very straightforward in Autogen. Now there are a few more components in my example system. There are termination conditions. So anytime a terminate keyword is sent by any agent, that can be considered for the termination of the overall conversation or overall loop which has been happening between several agents. Human input mode, human can interrupt. There are always stop buttons when a conversation is going on. If the user presses that, is termination message. If there is a custom message that has come out of any agent, and group chat max round. If that maximum limit, for example, here we define 10, but this group chat manager can also define a maximum limit of, let us say, 20. So at any point of time, to and fro messages have happened more than that limit between any agents, So that will be considered to be a termination of overall loop. So we have a manager in our team, we have our coder, we have our tester, and we have this reviewer agent, which works like a critique in our software development team. It's LLM powered code reviewer agent, obviously, provides quality assurance and constructive feedback to whom? To group chat manager. It says, okay, I have found that many qualitative issues, and then group chat manager decides, okay, I have this input from reviewer, can you do this, can you fix that? And then group chat manager itself can instruct the user proxy agent to improvise the process of testing, why these checks were missing, these quality checks were not there. It has got review responsibilities, check code correctness, reviews code quality and style, identifies bugs, this and that. And at the end we have a simple code snippet, how to define an assistant agent. Name, whatever you like, then system message, of course something bigger than what I have written, review code for quality correctness and best practices. LLM config, of course it need to consult LLM, and its key role is review and critique. So this is the overall system. And I have this one more box, conversable agent. This is a base class of in Autogen. All of those dark purple colored agents extends directly from this class, or there is always one more class in between which those agents are extending. So this is the overall working of the Autogen multi-agent system. There is no standard workflow. The gist, the soul of this Autogen is the orchestration of multiple autonomous agents. So what are the takeaways from the Autogen workflow? The paradigm behind Autogen is it's a multi-agent conversational framework for developing applications. Core ideas are defining multiple specialized agent. You can also define it. Yeah, we have made these objects, group chat manager and this and that, and the orchestration happens by the message exchanges between them. So the core idea is defining multiple specialized agents that collaborate by talking to each other to solve a problem or user task. For example, assistant agent, what it was doing, it was acting like a programmer in our system. And then we have user proxy agent, which executes it and acts as a tester. And we have a loop being created among all those agents until the task is completed. So the major components are, of course, the conversable agent, which is a base class for all of them. We have user proxy agent, assistant agent, group chat manager, and the function or tools registered with the system, which everyone can use. Autonomy, again, the autonomy is in the core of the system, distributed across agents. So every agent is autonomous. Complex workflow with different skill roles fulfilled by different agents working together. So that's a core idea behind Autogen, where you have multiple agents. They have their specialized job, and at the end they work together by passing messages, by speaking to each other to fulfill or to accomplish a bigger or complex task. By the way, while researching about this Autogen, LangChain and everything, I came across that Microsoft has one more framework being developed. It's relatively new. I think it hasn't completed its first year yet. That is called Microsoft Agent Framework, but I just gave it a brief look. It looks promising. I think in July 2025 they started it. At least I could see the commit from that time, but would be interesting. Perhaps I will spend some time in studying it. So this was all about the comparison between LangChain agent and Autogen. Now you might be thinking like, can't we do a multi-agent system? Can't we implement a multi-agent system inside LangChain? Yes, you can do. And then you might be asking, can't we do a autonomous agent? Can't we implement an autonomous agent using only LangChain? Yes, you can also do that. But every time you go backwards, you will have to implement more things to achieve your purpose. Now you can imagine if you want to convert this basic LangChain retrieval workflow to become an autonomous agent, how many things, how many additional steps you will have to implement, and you will have to make sure that they work as you expect. So that problem is already solved by LangChain agents by providing you this looping mechanism between agent executor and React agent. So this is kind of wrapper. Inside it they might be doing the same thing, but that's not your problem. You can still focus on your use case. Then if you want to have multiple such agents and you want to orchestrate, do you want to do it using LangChain agents? No, you want to shift to Autogen. So that's how these all frameworks are arranged or created, targeting specific use cases. I hope you liked the video. If you like, please do subscribe and like. Thank you.